you can look at two tables at the same time. We can right-click the Pittsburgh census tract and open that attribute table. So I have the census table and the census tract feature class attribute table open. And if I want to look at both of them at the same time, I can right-click the tab and move it over and hover it over one of the arrows here when this set of arrows appears. So now I have both tables open at the same time. Oops, I just undocked it, so let me dock it back. So now I have both tables open at the same time. So my poverty table basically just has information about poverty for each census tract in Pittsburgh. So each census tract has a unique identifier, right? A number that represents the state, the county, the municipality, and what tract number that record is for. So in this particular census tract, there are 803 people living below poverty. My feature class, which is what we actually see here in our map, so if I click this gray section here, it'll highlight which one of my census tracts I am clicking on. And the information about that census tract is basically just the GeoID number. We also have area that is land and area that is water. So if you have a census tract that maybe has 0 population and you're wondering why, if the land is 0 and the water has a value, that probably means that that census tract consists mostly of a lake or a body of water. So that's why you wouldn't have any records for it. So one of the most powerful things that we can do in GIS is to join data with each other using a unique identifier. And that would be the GeoID number in the census tract table and the attribute table. Right now I have a record selected. You see that only one record is selected. If I were to conduct a join right now, I would only join that one record. So it's very careful to make sure that before you process a join or before you do any other type of processing in your ArcMap, that you clear selected features. And you can do that in various different ways. You can just select this clear selected features icon here, or you can go to selection and clear selection, or you can go into the actual table and clear the selection at the table. So there are usually at least 2 ways to do one thing in ArcGIS, so I'll try to teach you all that I know. So let's join this data. I want my census tract to have information about the population poverty level. So to do that, you right-click your census tract layer and select Join and Relates and Join. This dialog window will pop up, and what you want to do is there's different ways that you can conduct a join. You can conduct a join using a table, or you can conduct a join based on its spatial location. Right now we're going to do a table join. So I'm taking information from an existing spreadsheet and adding it to my feature class, my census tract feature class. So it's going to be joined from an attribute table. So it's asking me, choose the field in this layer that the join will be based on. We know that it is the GeoID, right? So if I move this out of the way, the GeoID 10 is the column inside my census tracts that represents that unique geography identifier. So GeoID 10, and we know that we're joining to the Pittsburgh census tract table, and that unique identifier is GeoID 2. So we find that here in our, oh, it's not there. What do I do? Well, there's this thing called data types in GIS, and I won't get too much into it in this video, but data types just basically means the type of data that we're dealing with in each column. So is it a number or is it a text? In GIS, text is the same thing as string data type. So to find out what my data, so I know that this and this is what I need to join, but it's not letting me. So let's identify why. If you right click the column heading and select properties, you'll find that the GeoID is a double. It's a type of data, it's a data type. And in the census tract layer here, if you click properties, it's a string. So basically we're trying to join unique identifiers where one is an apple and the other is an orange, and that's not going to work. So we need to find a way to make this equal to that as far as data type is concerned. That's something calling add, we call that add fields. So let's go back, let's make sure, so you see how there's this little dotted line around Pittsburgh tracks, that means that's the active table. Let's make sure that that is the active table. And let's add a field. And to add a field, you go to Table Options, Add Field, and we're going to call this GeoID 2. Oops, ID 2. And we're making it a double. Why are we making it a double? That's because in our census tract table, our unique identifier is a double. So we need this to also be a double. Great, so now we have an apple here, an apple here. We should be able to join. However, all of my records have 0. Well, there's something called the field calculator, which is a great tool. Keep in mind, field calculator cannot be undone, so be careful with the field calculator. When you calculate a field, it's there forever. So if you're going to be working with the field calculator in the future, perhaps you want to have a backup of that original data. Okay, so I have a new column. It's GeoID 2, but it doesn't have any of the information that I needed to have, the unique identifier for each record. I can just copy that the column from this GeoID 10 field to this GeoID 2. The way I do that is I right-click GeoID 2, I select Field Calculator, and here are all my other fields in the table. I want the original GeoID 10, which is now a text, meaning a string. So I want everything in this column to be equal to everything in this column. So I just double-click. So basically what the field calculator will do now, it will make GeoID 2 equal to GeoID 10. Click OK. Okay, so now I'm going to move this column over next to the original so that we can just get a better look. So now you will see that my GeoID 2, which is a double field type, is the same as my GeoID 10. So now I'm ready to do the join. I have nothing selected, I'm good to go. So I right-click my census tracts, Join and Relates, Join, and now I have a GeoID 2, my new GeoID 2 column that we just created. And with my census tract table, I would like to join it too. Now it shows up. Now there is an option, GeoID 2. In the census tract tables. Very important to always click Validate Join. Now what that's going to do is very important to always click Validate. Very important to always click Validate Join. Now what that's going to do is it's going to check to make sure that you have a certain number of joins. You may have a few error messages and other joins in the future, but basically what you're looking for is how many records joined. A total of 137 of the 137 records joined, so you have a successful join here. So at that point you would say OK. And the reason you do that is, if you had, in our census tracts, we have a total of 137 polygons. If that table told you that 60 polygons joined, or 60 of the 137 records joined, then something is wrong and we need to investigate. In this case, we had a 100% join, so we're all good. So this is a temporary join, meaning the join is here just temporarily. I can actually remove this join, and that will no longer, the data that came along, the data that came with that join is no longer there. So now in our census tract table, we have all the same columns that are in this census table. So we have population below poverty, population below poverty. We have population with poverty status, population with poverty status, the GeoID2 that came with the table, and the object ID that came with the table. Those are the records that are now at the end of our census tract table, and all the other records are the original records of the table. So in order to make that a permanent thing, I'm going to close my attribute tables. I don't need this anymore, and open up my ARC catalog. I do not need that. What I want is a permanent layer that has this data baked into it. Meaning, if I were to close my map right now and without saving my work, then I would actually lose that join that I just did, because that join only exists in our map. In order for it to exist in our data as a permanent layer, we actually have to create it as a data layer. So let's do that. First, let's save our map. Let's go to File, Save As, and let's navigate to the folder, our GIS folder. I'm just going to go ahead and put it in my Data Assignment 1 folder. And I'm going to call this Assignment 1.mxd. Okay, now our map is saved in that folder. So there it is. There is our .mxd. The other thing that we should create, so in that folder we also have all of our shape files that are separate data layers. We're going to create a new shape file. So let's put that in a geodatabase, an actual relational database that is a container for our work. So right-click the folder, the assignment number 1 folder in your catalog, select New, File Geodatabase. And we'll call this Assignment 1. So now we have a geodatabase set up for future layers that we create, either through geoprocessing or spatial joins or tabular joins. Let's right-click that geodatabase and make it a default. Now what this means is anytime I run a tool or a process, it's going to automatically send my layers to my default geodatabase for this map. And just going back to creating a new geodatabase, we always want to create file geodatabase, not personal geodatabase. File geodatabase is the type of geodatabase that we will be working with going forward. Great. I'm going to unpin the catalog now so I can focus on my map, and layout tool, just kind of zoom into that a little bit. Okay. So what I want to do now is I want to make this join that we just did a permanent thing, and the way that we do that is we right-click census tract, select Data, Export Data. And since we set up that geodatabase as our default geodatabase, we can now just click here, go to default, and it will automatically send it to our default geodatabase. So let's call that Pittsburgh Census Tracts. And it is not a shapefile. It is a file and personal geodatabase feature class. So what is the difference? We'll get into that a little later in the semester, but just know if a feature class layer is going into a geodatabase, then it has to be saved as a feature class. If it's just going to like a regular folder, like if it was just going into that assignment folder, then it would be a shapefile. So those are the other two shapefiles that are in there. But since we're putting this in our default geodatabase, we need to make sure that we change the type as file and personal geodatabase feature classes. And click Save and OK. So now it's in the process of exporting. It exported everything. And it's asking, do you want that new layer that you just created in your map? And you say yes. So now you will see, since our layers are being displayed by source, you have in your assignment folder, you have the original data that I sent you. And in your geodatabase that you just created, you have this layer that you just created. I no longer need the original census tracts because I just wanted it so that I can join it with my census tract table. And I also no longer need that table because those two layers have now been merged into one layer that is in your geodatabase. So let's talk a little bit about the symbology. To change the symbology, the way that the map looks, go to right-click the layer, select Properties, and select your Symbology tab. I want to symbolize this by colors, by quantity. So I want the colors to represent the numerical value of something. So the way that you do that is you select Quantities, and you want to show, you want the quantity to be based on the population that are living below poverty. It automatically gives you this default colorful type of symbology, but you can change that here. I usually like the background layer to be something that's kind of like monotone or not very bright, doesn't have very much like color hierarchy. So you also have to make sure to fix that, right? So wherever there's a census tract where there's 0 people to 136 people that are living below poverty, that should get the lightest color, right? Because the darker the color, the more the intensity. It gives the viewer the impression that this is a higher number value. So to fix that, let's just left-click the symbol and select Flip Symbols. Great. So now the darkest color represents the highest value. And for some reason, it automatically gives all these decimal points, and it doesn't have commas in my numbers. And if we add legends to our map layers, that's going to be a very ugly legend. So let's left-click Label, Format Labels, and let's change that to 0 number of decimal places, and let's show 1,000 separators. That's basically commas. And click OK. So now these numbers look like they make a little bit more sense. And then we have to choose what type of classification. So let's talk a little bit about what that is. Before we get into the classification, let's talk a little bit about the color. So this is an example of a map that just has, it's a bad map because it has too much color hierarchy. Can you tell what the map maker is trying to express here? It's difficult. All the colors on all the layers are so bright. That's what you called in figure. In figure meaning it means that you assign a bright color so that it's not in ground, it's not in the background. A better representation of that same map is where all of the background colors that just give you, all the background layers that just give you context, such as boundaries, political boundaries, and streets, they're given like light gray colors, putting them in ground. And what really the map maker is trying to show here is where crimes are occurring by type. So the red little guy here, the dead person, that's a homicide. This is a burglary. This is an assault. So this is what we want to highlight in the map, is where these types of crimes are occurring. We don't want to highlight the background. So that's the difference between when layers are either in figure or are in ground. So a choropleth map, which is what we're in the process of doing here with our map document, is where you represent the polygons by color, and the color is some kind of numerical value. So in this map, what we're showing age. Where is the population ages 65 and up? Now, there isn't much contrast in these colors, so a better way of displaying this data would be to have more contrast. It'll give us a better sense of where maybe there is higher population, higher senior citizen population in one area versus another. And the way that we assign this type of color hierarchy is by assigning a classification. So if we go back to our map document for a second, to get to that classification, you click on the Classify button. So this is a data distribution curve. So let's look at what a classification window, what we're really doing here. There are many different ways to classify your data. ArcGIS will always just automatically assign natural janks, which is an algorithm they use to assign the different break values. Break values are where your colors start to change. So at 367, the color goes from white to a gray color. So that's basically what the break values are. So let's talk about equal intervals. What equal interval does is it divides the range of attribute values into equal size subranges. So it's an equal number in the break values. Now this particular way of displaying that data can kind of be deceiving, because all of your, in your data distribution curve, most of your values fall within this 0 to 9 range. And so breaking it up into equal intervals may not be the best way to symbolize your map. This is what your map looks like on an equal interval. So again, not good for highly peaked or skewed data distributions. The quantile method is it's a method that I like. It's well suited to linearly distributed data because features are grouped by the number in each class. However, the numbers can sometimes be misleading. So let's look at that same map and see what it looks like represented in a quantile. So because the class ranges are specific to individual data set, it's difficult to compare a map with another map. Another way, and this is my favorite way to show the distribution of data, is the natural breaks, or the janks. So classes are based on natural groupings inherent in the data. So ArcMap identifies breakpoints by picking class breaks that best group similar values and maximize the differences between classes. The features are divided into classes whose boundaries are set where there are relatively big jumps in data values. So I recommend that you use the natural breaks and janks. And so to look at what that same map looks like, this is the natural janks for the total number of Department of Defense facilities. Right, so it's a better representation. So for instance, in Nevada we have a total of 14, whereas you know, most of Florida is between 0 and 2 and 3 and so forth. So it just kind of better represents that data. So in this map is telling us, here's where you have the most with the colors, right? So if we pretend that these numbers aren't there, the colors are telling us here's where we have the most and here's where we have the most. We have quite a few up here, and then this is where we have the least, right? And then you can also set your, you can always just adjust the numbers yourself manually. So that's also an option. So there's another way of showing it. So if you feel like you want to manually pick your classification, that is okay. So we're going to keep the natural janks. Going back to our ArcMap document, we're going to keep the natural janks and click OK. And click OK again. And now our document has the census tracts colored by the number of people that are living below. So that concludes our introduction to ArcMap for now. When we meet again, please bring this map with you. The map should have the Pittsburgh census tracts with the poverty data joined, and the classification will be the natural janks. Using a color scheme like this or similar to this, where it's kind of like a in-ground color palette. And also make sure that you have your Pittsburgh serious crimes added to your map. Your MXD document will be named titled Assignment 1. It'll be in your Assignment 1 folder with your geodatabase that you have just created.